I'm going to show you how an Arduino Leonardo, this thing right here, that's attached to this wire that has this display. I'm going to show you how these things are overclocked by natural frequencies from other devices, and higher frequencies than what they normally operate at are actually overclocking the device. And it runs faster than it was really intended to run. And we can also overclock it with a device called a Tesla booster that gives off microwaves all the way from gigahertz up to X-rays. So look, I'm going to show you here how this works. I'm going to zoom in. That's 32,000 right here where my 32,000 mark is. It counts immediately in this loop, 1 second. And as soon as it does, the very next second, or part of the second, in a fraction of the second, which is supposed to be 9600, as you'll see here, serial begin 9600 baud, it's bits per second. And if second counts to 32,000, immediately after it counts to 1. If it equals 32,000, if it's greater than 32,000, it will put a 0. Okay, if it's not greater than 32,000, it will be a 1. Okay, so we want to show how that works. So we're going to upload this. Upload. We're going to show the uploading. It uploaded. It's flashing. Okay, we got a 0. Now I'm going to change this number to 3,500. Or I mean 35,000. I keep saying 100, but it's 35,000. I'm going to upload 35,000. It uploaded. Uploaded. Now it's a 1. It does not reach 35,000. It doesn't reach 33,000 or 34. It reaches 32,000. And then that is 3 times 9,600, or more than 3 times the normal operating range, which means that frequencies are intercepted by the chip, and when they are, the oscillator that's on the board is receiving radiation from the room that's normally much higher. So what it does is it overclocks the chip, so it's actually 35,000 bits per second instead of 9,600 per second. So that's what I wanted to show. So I'm going to drop this back down to 3,200. I just changed that to 32. Now we're going to go up here. I'm going to go to Sketch, Upload, goes across, go out, goes to 0. Okay? That means that we can overclock computers, especially CPUs, and their oscillator circuit. Where they have an oscillator like a crystal oscillator or a voltage controlled oscillator, if we input a frequency that is ionic or slightly voltage inducing, that frequency will carry over into the oscillator circuit, and it will make the entire system, if the voltage and the amperage is enough to increase a spike in the overall oscillator carrier, it will carry that into the processor, and the processor will then ramp up into a higher frequency band. So that's what's happening here. Naturally, these are supposed to be at 9,600, but this is really at 32,000 bits per second. Thanks for watching.